I seem to be missing several memory engrams. Oh, there they are. I don't know. That's just what these little things reminded me of. These are framework desktop tiles. Framework desktop tiles. This is the Strix Halo 128 gig framework desktop. We've taken a look at the platform before in a mobile form factor. Now we're taking a look at it in an expandable desktop form factor. It's the mobile CPU in a desktop, 128 gigs. A lot to be excited there about if you are into machine learning or AI or any tasks that require a lot of compute. This is the monstrous APU. This may be the first sign of a major sea change in the computing industry for enthusiasts, mobile machines, desktops, the whole industry. I may refer back to this video to say this was where it all started because of how powerful and how different Strix Halo is. Now in a convenient desktop form factor from Framework. If you're not familiar with Framework as a company, their corporate philosophy is something that I like and something that I can get behind. Upgradable, modular, repairable, documented. They want you to have a good computing experience, and they're willing to put their money where their mouth is. I spent a lot of my own money on Framework stuff over the years, laptop, everything else, but Framework sent me this because this is a little bit early, which is exciting. Thanks, Framework. So, this is a lot of fun. This is pretty much what you get for your unboxing experience as well. Left panel translucent. A lot of the time if you get a Framework, you can get it pre-assembled or you can order a kit. This is our accessory box, which is cool. We got our Framework desktop kit. Ooh, there's a handle. I love me the carry handles. If you ordered storage, optional storage, it will be in the box with your order. The memory is soldered, it's built in, it's not upgradable. This is because this is designed to be a mobile platform first, and second of all because it is a quad channel design. This thing has as much memory bandwidth as a TRX 50 Threadripper. Foreshadowing, we'll talk a little bit more about that. CPU fan kit for the Framework desktop. And then here is our Framework desktop, the machine. For the rear I/O, we've got HDMI, two USB-C ports, those are USB 4, 2 DisplayPort connections, and 2 USB Type-A ports, along with 5 gig Ethernet, and a combination of headphone microphone jack. Got our power supply connection at the bottom, which takes a standard power supply connection. We also have 2 of the Framework modular ports at the front. Also in the box, we have a Framework screwdriver to make assembly and disassembly a little easier. Also got a bunch of Framework stickers in the box, as well as some handy Framework documentation. Now for what's accessible here, we got our single 2280 M.2, which has a pretty cool feature, I'll show you in a second. And then at the top edge of the motherboard, we actually have 3 4-pin fan headers, a clear CMOS button, so in case you ever need to reset the BIOS or anything like that, you've got that option. And there's an RGB header, an ARGB header. Also tucked away here is a PCI Express X4 slot. Now in this case, that slot's not really accessible. I mean, you could maybe cram something really small in there, but it's not really designed for anything to be put in there because the power supply is encroaching on the normal keep out zone or safe zone for that PCIe slot. If they'd made this 5 or 6 millimeters taller, you probably would have had enough room for something that's half height there, or maybe you could have done a half height slot here, but no GPU or anything like that. This card slot can only deliver 25 watts as well. So even if you get creative with a ribbon cable, most GPUs need 75 watts. This is only designed for 25 watts, so keep that in mind. To install the top handle, and also I think it's easier to get at the fan header, you can slide the top off. And look, they leave you little holes to make it even more accessible, which is pretty fun. So you don't actually need to take out the orange screws at all because they cut a little access panel for you. This little baffle improves airflow because it's going to pull more air from the outside as opposed to letting it recirculate air inside the case. You'd be surprised how much of a difference something like that will make. When you're tightening the screws, you don't need to over tighten them. You just need to, you don't even really need to snug them. You just need to make it so the plastic doesn't rattle. There's also another optional fan at the front, an 80 mil. So you can get an 80 millimeter fan that's up to about 25, 30 millimeters thick, 25 millimeters thick, let's say. Now for installing your M.2, you're gonna need that tiny bit. Very impressive. It's a spring-loaded cover for the heat spreader for your M.2. Now for this, we're gonna be using the SN7100, the WD Black. It's a very high-performance Gen 4 NVMe. Sometimes with the thermal pad, there's a removable plastic material. That was not the case in my Framework, and I'm not sure if it's because that's how they all come, or if that's because, you know, this is like an early version of the Framework desktop. So double check that the thermal interface material, you know, doesn't have a plastic protective cover on it, because it needs to make thermal contact with your M.2 to provide appropriate cooling. The other side comes off by just lifting it. You can slide it that way, and that exposes your other M.2 slot as well as your upgradable replaceable wireless card. The wireless card in our Framework is the RZ717. This is the AMD recommended solution, but there will be some vocal objectors among you. Fine, replace the M.2. Totally user serviceable, you can do that. It's all good, right there it is. But my experience with the RV717 is that it has improved dramatically over the last year, and whoever it was that needed to get flogged to provide proper Linux support for this wireless solution has apparently been flogged, because it has been dramatically better since kernel 6.14. If you're on anything older than that, it can be dicey. The backport support has been a little hit and miss, but for Strix Halo and for this specifically, generally I've had a great experience with this Wi-Fi solution since 6.14.2 or 3. But if you want something else, Framework. I also really like here that they've got the spring-loaded heat spreader, the screws captured. This is a first-class M.2 experience, and so if you wanted to add another 2 or 4 or 8 terabyte M.2 for additional storage, you've got the option. If you want to go totally off script and print a whole other different side with some sort of crazy maniacal breakout thing that lets you do unholy experiments, that's an option too, because you got 4 PCI Express Gen 4 lanes just right there. So the handle situation is a lot of fun. You install it by unscrewing it into where it's supposed to go. And there you go. Is that awesome? Now the front's magnetic. We haven't gotten to the fun part with the front yet. But we do have our left translucent side panel. So another cool thing about the design is that you want to add your panel before you put the top on, because when you put the top on, it locks the panel in place. In the accessory box, we've got our expansion modules, a power cord, and the tiles for the front. You can accessorize the Framework and make the front all your own. Hey, look at that. They printed an L1 tile. That's pretty cool. Thanks, y'all. All right, and then we've got our USB-C accessories. Now, for the most part, this is compatible with the existing accessories from Framework. And so if you're not familiar with this, with Framework, one of the things you can do is customize what ports you want. This is true of a laptop or anything else. Oh my goodness, what a little firecracker this is. Okay, we've got the results in, and I've decided to break the review into 3 parts. We're gonna keep talking about the Ryzen AI Max 395 Plus and some of the configurations the Framework has. But then after that, we're gonna talk about the general Linux experience. It got so long-winded, I'm gonna break that out and put that on the Linux channel for a long Linux experience, but we'll talk a little bit about it here. And then also the Windows experience. This is a first-class Windows citizen. We also need to talk about AI. And it's tough because I don't know if I should talk about AI in the context of Linux versus Windows, or talk about AI as kind of a standalone for this platform. So we'll talk about AI as a standalone platform, and then the Linux and Windows parts of the AI. So that's what the chapter markers are. That's why it's a little complicated. If you're not read in on Strix Halo, that's also the code name for the chipset here. It's Ryzen AI Max 395 Plus is what you should read from that. But Framework makes 2 other versions of this. There's the Max 385 32 gig. That's an 8-core, 16-thread situation with an 8050S graphics. Max Plus 395 64 gig, and Max Plus 395 128 gig. This dovetails a little bit with the conversation that I want to have about how this can change the trajectory of the industry, but the downside is that it's not upgradable, but the upside is that it is ridiculously fast. This thing measured like 215 gigabytes per second memory bandwidth. That's as much bandwidth as TRX-50 Threadripper in this tiny little package. At idle, it's using about 12 to 13 watts. Under full load, it's about 150 watts, 160 watts. This Framework also is selling the motherboard individually. The power supply is overkill. The fan that I've got is a Cooler Master fan, but you can opt for a Noctua fan or whatever you want because, again, Framework repairability, etc., etc. But Framework even put a little bit more work into the power supply. It's a 400-watt power supply, which is overkill, but it also has a Delta fan, and I can't hear it. There is a cold air, or like a fresh air duct that they have. That's the little circular port on the side that brings in some air from the front. So it'll sort of like bring it in this way and take it out the back, so it's not really using the front for intake, even though the tiles do have little vents in them. It definitely does not help cooling. If you get creative, you could use that with a 25mm by 80mm fan. You can also 3D print tile accessories. So there's a lot of fun that you can have with this platform. Did you notice that Framework had the literal touch grass tile? Like, it's a tile for grass, but I was looking through the metadata and it's a literal touch grass tile. I have a better idea. There you go. There's a planter tile. You can touch real grass. That's the whole point. It's touching real grass. And you can do that because it's Framework and it's modular and it's upgradable and you can design your own stuff. The model for that's on the forum. It's got the HDMI 2.1 at the back, dual USB 4, which I've confirmed working, and dual DisplayPort and USB 5. We'll talk more about the USB 4 in a second. HDMI, you should be aware, on Linux is kind of a second-class citizen. It's HDMI 2.1. If you're going to run Windows on this platform, you're not going to have any problems. Adrenaline works great. In fact, I've got a beta version of Adrenaline that unlocks AI things you haven't seen before. We'll talk about that in the AI section, which is amazing to see AMD put work into that, especially after I interviewed Andre at AMD at Computex in June. So it's like I get the Windows roadmap a little more now. If I were buying this platform, I think I would go for the 64 or 128GB configuration. The 32GB configuration might make sense in some narrow scenarios. I don't think the 32GB configuration makes sense if you're doing AI workloads or anything like that, but the 64 or 128GB version with the 8060 graphics makes a big difference. And again, if you're not familiar with this platform, this is the APU to end all APUs. AMD's platform here is incredible. The GPU that's built into this APU is equivalent to a 4060M. You're getting discrete level gaming performance. I'm getting 60 FPS at 1440p on Clar Obscur with pretty high graphical fidelity settings. It is monstrous. Now, the 128 gigs in my configuration is shared between the GPU and the CPU, and this is another platform thing, and this is a thing that a lot of people get wrong. In the past, because of legacy and software compatibility reasons, you would designate if you wanted 8 or 16 or 32 or 64 or 96 gigabytes of memory dedicated to the GPU, and that would be reserved, and then the rest would go for the system. But on a platform that supports unified memory, the hardware does. You don't have to do that. You don't have to reserve memory for your GPU, but your software has to understand that that is a unified platform. You get that with like the HIP allocate stuff if you're going down the ROCm platform, and your software will use it's like, oh, this is unified memory, I should allocate memory using the unified memory allocator. That works and is completely fine, and it is fully plumbed in for gaming. So check out Clar Expedition 33. I'm playing here at 71 FPS, 50, 60, 71 FPS. But look at the VRAM in the corner. It's 512 megabytes. The platform is using the shared memory configuration as it should be. On the console here, in Linux, it's showing 128 gigabytes of memory as it should. And if you have to, you still can reserve 96 gigs of VRAM through the Adrenaline software, but realistically, you probably won't need that. Framework fully supports Bazzite, which is great. That is an immutable distro. Bazzite is interesting from a developer perspective. You really want to run, it has a facility for creating and running like other distros, a la WSL, if you're familiar with WSL, but it's not really a virtual machine, but it's just sort of a virtual environment because of the immutability aspect of Bazzite. This is great for troubleshooting and it's like, did somebody configure their system in a weird way and now we have to spend hours and hours and hours reverse engineering what thing that this noob user did in order to restore the system to a working state. Those kinds of problems go away with an architecture like Bazzite. The problem is that if you want to get into development and do other things, like I wanted to install, the NVIDIA C compiler on this, and Bazzite doesn't really give you a clean way to do that, or like NVIDIA SMI and things like that, even when you rebase to the NVIDIA version of the Bazzite distro. God forbid that you have NVIDIA and AMD GPUs in the same platform. Spoiler alert. But Bazzite is incredible for gaming, and you can get 4060 level gaming performance out of this platform, and it is fantastic. You will get the similar gaming experience, even down to the 32 gig model, even with 8 cores, because 8 versus 16 cores doesn't make a huge difference for gaming. The 8050M is a surprisingly weaker GPU from the benchmarks, but I have not personally tested it. And you have to remember that this is also a platform that is meant for laptops. And so it is awesome that AMD has a power envelope from 10 watts to 150. This thing can turbo normally up to 120 watts, but Framework's actually given it a little bit more headroom up to 140 watts. And that's because we've got that giant 120 millimeter cooler on the side. Laptops don't have that. And so this is significantly measurably more performance than the equivalent Strix Halo laptop. You can do not just casual gaming, but actually AAA gaming at good frame rates, 1440p. Heck, I could, with medium low settings, I could do 4K in a lot of games natively. But 1440p with upscaling is pretty good. Now, if you turn on frame generation, it's a whole other story. Even better. But real world gameplay on Expedition 33, on Cyberpunk 2077, on a lot of these games, fantastic. And the performance parity was pretty even between Linux and Windows. A lot of titles are actually faster on Linux these days than Windows, kind of surprising. Helldivers 2, notably, considerably faster on Linux than Windows, owing to the anti-cheat. The anti-cheat is less onerous on Linux than Windows. Who knew? And yes, this motherboard is available separately. If you're looking at this and saying, gosh, I really would love to have access to that X4 slot that's blocked off in the Framework chassis, don't buy the Framework chassis. Just get the motherboard and put it in your own case. You can do that because it's Mini-ITX, Mini-ITX compatible. A lot of the enthusiasm I have for this platform does come from the Ryzen AI Max 395 Plus Strix Halo thing, because AMD has done something interesting and innovative and may actually be disruptive depending on how the market picks it up. So, with that, let's talk about the Linux experience. Okay, the Linux experience is first class. Framework has a guide that they're working on, I think for Fedora. Bazzite works out of the box. Windows, of course, works out of the box. You need a newer kernel. So understand that the best AMD experience here depends on having really up-to-date Linux firmware, Linux-firmware, and really up-to-date kernel, like 6.14, 6.15, 6.16. There's a lot of stuff in 6.16. If you're buying this platform to do machine learning experiments and that sort of thing, then I wouldn't recommend Bazzite at this time. Cache OS, and that's what we have. The video for this that's going to be on the Linux channel is the Cache OS experience and plumbing that goes with this. And it is a first-class experience. It's great. Suspend, sleep, everything works. I mean, this is basically a laptop platform that doesn't have a battery or anything like that. Even our 5 gig NIC here has been pretty well put together. The BIOS experience is a first-class BIOS experience. It's inside BIOS. And so Framework it's not anything, if you're familiar with Framework stuff, it's not anything new to Framework. But they're power users, they're Linux users, they know. They've tested a lot of the weirdo edge cases. I would like to see more options in BIOS, because I know the AMD platform exposes, there's a lot of stuff under the hood that could be exposed, that should be maybe a little more exposed for that sort of stuff, but hey, what are you going to do? The only real complaint that I have about the BIOS is that by default, the BIOS version that I'm on, you can choose a half a meg of reserved memory, and then because this is a 128 gig platform, I can do 32 or 64, and those are my only options. I think 8 gigs as a reserved VRAM instance for legacy software compatibility, because generally legacy software compatibility is not going to need more than 8 gigs, AI software accepted, it would make sense as a hard-coded option. But that also, gets rid of the ability to run something with 96 gigs. And this is why there's a lot of confusion and a lot of people step in. It's like, I can't run a 96 gig model on this. You absolutely can if the thing that's running the model can allocate the memory in order to do that. So in addition to this being a first-class year of the Linux desktop experience and a surprisingly capable gaming experience, if you care about that sort of stuff and you want the insane memory bandwidth and an absurdly snappy machine in the most ridiculously small power envelope possible, this is it. But if you also want the AI capabilities, then your purchase starts to make even more sense. You're paying a little bit of a premium for that first group of experiences, but the 200 gigabytes per second memory bandwidth, like Threadripper, you feel it, you really do in the desktop experience. But if you're going to go the AI route, then 64 to 128 gigs of memory makes sense, and I actually would probably lean on the 128 gigs of memory thing. Now, off roadmap. I did something unholy. This is the Cooler Master dock that I always love to use for testing. This is an SFF 4000 ADA. This is low power, it's a 75 watt card, it has 20 gigabytes of VRAM. I have just connected that via USB 4, which actually is worse than your other options. All right, so with this setup, we've done something unholy. There's a whole other video on this you could watch, but you can check out the Linux channel video, which will walk you through step by step. We're using the 20 gig GPU for the KV cache and the dense layers on a 520 billion parameter model. And this is doing all of the work in CPU. This is with the IK fork of llama.cpp. Llama.cpp LM Studio doesn't do this. It doesn't do this as well on the CPU. And actually, there's a new trick since the video that I did, which is this is using AVX 512 acceleration. That's pull request like 603 or 620, something like that. That pull request enables the AVX 512 pathway on Zen 5, which is good for like a 40% speed up on prompt processing and some other scenarios with the Calracal IK llama.cpp. Anyway, bottom line, with our Thunderbolt 4 or Thunderbolt compatible USB 4 enclosure here, connecting this GPU, making it available on the system, even with that bottleneck, 8.17 tokens per second. And we're using 117 gigabytes of system memory and 19 of our 20 gigabytes of VRAM, and we have about a 25K token context window. This also, to be clear, this is not using ROCm. ROCm actually is good, but this is giving us an extra 20 gigs of memory to play with, which makes a big difference with that model because it clocks in at about 138 gigabytes. It won't fit in 128 gigs by itself. And yes, the USB 4 interface is a bottleneck. If you go Oculink, if you go, direct PCIe Gen 4x4 connection, you lose the Thunderbolt overhead, you lose the USB 4 overhead, and you get twice the bandwidth per channel because it's still 4 channels. And so you can get upwards of like 10 tokens per second, give or take. Most of this AI stuff depends on memory bandwidth, and this platform has memory bandwidth in spades. It is, like I say, it's as good as TRX 50 Threadripper. Your entry point is 16 cores, but compared to the cost of a Threadripper system, which would be upgradable, there's a lot of reasons you might choose a Threadripper system over this, but look, it's so tiny and you can just carry it with you and you can't actually hook up other stuff. I think if you're going to go that route, you probably wouldn't get the Framework desktop case, but you would get this motherboard because it has the PCI X4 slot. Now, the PCI X4 slot, it's only 25 watts. You can't shove a GPU directly into that, but you can get a riser cable that provides supplemental power. And, this 400 watt power supply theoretically could power our little SFF 4000 GPU from NVIDIA, but this is the unholy AI development platform. You can work with CUDA and do CUDA stuff. That's what we're doing here in Cashy OS. But you can also work with ROCm and the ROC stack on RDNA. Just remember that AMD has, RDNA versus CDNA. What AMD has in the cloud with CDNA and ROCm is a first-class experience and has always been a first-class experience. Your experience with RDNA and ROCm doesn't really reflect on the experience of CDNA in the cloud. And AMD sort of recognized that that's a problem a long time ago, but they haven't tried to turn on a dime and overpromise on that, in my opinion. The community has picked up a lot of slack. The community doing work, like the randos working on ikllama.cpp, incredible work, frontier class work. It is shockingly good. But AMD has actually released a lot of amazing things for Graphics 1151. That's the code, that's what it's referred to as in the Linux land for the 8060, the model, the GPU that's in here. And I don't want to, AMD engineers are doing a lot here as well, but you can tell that a lot of the AMD engineering efforts are focused on CDNA. That said, the Windows experience is also shockingly good. Just to plug the Windows section just a little bit, the plumbing for PyTorch and all of that in Windows is turning ROCm on Windows into a first-class experience, but there is not perfect functionality overlap. Some things work in Linux that don't work in Windows, and vice versa when we're talking about the RDNA platform, which is what this is. And there's a lot of little examples that make me say that about this platform in terms of AMD giving all the attention to CDNA and not RDNA. One of those is Graphics 1100 is still faster than Graphics 1151. This is better. It shouldn't be it shouldn't perform worse. and it has to do with low-level hardware stuff, I think, like WMMA kind of things, and it's on AMD's radar. There's an issue for it on GitHub, but it's the Graphics 1100, which is an older RDNA graphics platform, is like 1.5 to 2.5 times faster than Graphics 1151, and that really should have been fixed like in June, or like, you know, here we are, basically August. At the same time, AMD does have some serious engineering wins, which is the Vulkan backend for deep token response. Like, I'm asking for things that require a long token response here. The Vulkan backend is faster than CUDA on CUDA hardware. That's some seriously good software engineering. Good job, AMD. Oh, if you do decide to off-road it and go the 4000 FFF plus the Strix Halo AI 395 route to have the best of both worlds, 250 watts for that enchilada of AI is incredible efficiency. This is the best of the best from NVIDIA's power efficiency with 20 gigs of VRAM and the best of the best from AMD in terms of power efficiency for the overall platform. And together they combine into an incredible AI appliance. Now, you take away CUDA and you take away that, and you just want to run this with normal models, like a non-quantized 70 billion parameter model. Can you do that? Yes, you absolutely can. And you can do that on Linux or Windows. I talked about the BIOS things, like, oh, you can only pre-reserve 64 gigs, so most of the software I want to use is legacy and doesn't understand the unified platform. And so, you know, 70 billion, the software has been patched. Like, you may be able to, you might have some hoops you got to jump through, but it'll work and be fine. Now, I mentioned how I would refer back to this video as sort of the stake in the ground. It's like, maybe the industry is changing, and that's interesting and exciting. What I meant by that is that this approach, laptop processor in a desktop motherboard, has the potential to disrupt things, I think, for what would be 6 and 8 core system builders. I mean, you can get an affordable AM5 motherboard and an affordable AM5 CPU, and then you've got a really amazing upgrade path. Like, maybe you get, you know, this is an X870, but you could just as easily get a 600 series motherboard because those are all super upgradable. Then you have an upgrade path. You start with a 6 or an 8 core CPU, and then maybe you get an X3D CPU, or maybe you upgrade to a 12 or a 16 core CPU. But I think that this kind of thing is going to get more expensive and move more into the enthusiast category, and smart and cost conscious shoppers are going to move toward mini PC CPU on a motherboard. And yeah, a lot of the time the memory is not upgradable. Sometimes it is, sometimes it isn't. In this case, it's not upgradable because it's DDR5 8000, 4 memory channels, cost, etc., etc. Maybe we'll move to a situation where these mobile CPUs in a desktop form factor support things like CXL memory expansion. I mean, CXL memory expansion has worked surprisingly well. And so you could start with a 64 or 128 gig system and then get a 64 or 128 gig CXL module. And as long as your operating system is smart enough to know that it's got fast memory and slow memory, which Linux is already handling that like a champ, I don't really see that as much of an issue for desktop. So you could start with the low-cost desktop and then do that. And then for the enthusiast desktop, maybe it's triple or quad channel memory that's even faster, even beyond DDR5 8000. And maybe it has more of the traditional features, but that platform is also going to cost a little more. But it's probably going to cost less than Threadripper Pro, but give you some of those enthusiast class features. This is a super enthusiast class because of the memory bandwidth and because of the features. The only thing that they could do to make it better is just more PCIe lanes. So, what's the Windows 11 experience like then? It's a first-class citizen. Look, I'm playing Star Wars Outlaws, where you watch a literal ad for both NVIDIA and Intel at the start. And if they can't sabotage the performance in Star Wars Outlaws, this is 1440p. This is a surprisingly playable experience. Installing Windows really couldn't be easier. At the time that I'm doing this, Framework makes available a driver pack that you can install, and there's also a boot time installer for the Wi-Fi. So if you need to install Windows using a wireless internet connection, the wireless antennas are actually in the front here. It's a pretty clever integrated design, and they're quite capable. But there is because it's a sort of a new wireless chipset, there is a driver that you can use to set up Windows. And so there's steps for doing that in the Framework installation guide. If you just install Windows from USB and you don't need the wireless, you can install that later with the driver pack that Framework has to download. Thunderbolt compatibility via USB 4 also works in Windows 11. Good job. You're going to want to run Windows 24 H2. You don't want to run anything older than that. Windows 10, or it's going to be problematic. The Adrenaline drivers work pretty great and all of that. Now, if you're going to do AI on Windows, that's a deeper conversation. We'll talk about that in just a second. But first, the benchmarks. What does this thing look like in terms of raw compute? And what does this thing look like in terms of gaming performance in Windows with our APU here, our 8060? As always, let's start with the productivity benchmarks and take a look at 3D Mark and all of our artificial benchmarks that go with that, because why not? Now, our comparison system here is a 9950X plus an RTX 5060 Ti. On the one hand, cost. Really, it's like, okay, let's look at cost parity. Does this make sense? And to be clear, that 9950X is only half the memory bandwidth, but the 5060 Ti is a dedicated GPU with 8 gigs of its own VRAM, so it's kind of like, is this really an apples to apples comparison? 24 versus 42 FPS with the 5060 Ti? Yeah, the dedicated GPU is going to do really well here. Firestrike 38801 versus 26584, but again, for an APU, this is really holding its own. Port Royal, 10,000 versus 6,000, 5,800 give or take. Speedway, 4,000 versus 2,000, 3,700 versus 2,197. I'm doing this to kind of show that this is really a game of memory bandwidth, because the 5060 Ti really doesn't have all that much memory bandwidth, but the Ryzen AI Max 395 Plus with twice the memory band, it's got as much memory bandwidth as Threadripper, is really holding its own here. And for the artificial benchmarks, it's looking like, oh, this is an APU, right? Well, I think you're going to be pleasantly surprised. If we take a look at the CPU profile on 3D Mark for one thread, a very, very similar performance here between the AI Max Plus 395 and the 9950X. The 9950X, of course, has a higher overall clock, the clock speed is higher for single thread, but it's still doing really well here for what is essentially a mobile part. We step up to 2 threads, and yeah, the 9950X is doing pretty well. 4 threads is like, oh, maybe the gap is narrowing a little bit. 8 threads and 16 threads. Okay, we've got a much larger gap at 16 threads, but we're also at a power deficit on the AI Max Plus 395. But still, for lightly threaded workloads, it's pretty close in performance between the 9950X and the mobile CPU. What about Blender with a CPU focus, right? Rendering on CPU. Ah, yes, things start to look a little more interesting here. Really not a huge difference between these two processors. Junk Shop, okay, the 9950X pulls ahead a little bit. Monster, same kind of story, but still, very similar performance. Using the GPU to render, of course, the 5060 Ti is going to clean up here. No surprises there. What about Cinebench R23? Very similar performance in both single and multi-core. Cinebench R24, also very similar performance. I always like to test CPU-Z, and again, very similar performance there. Geekbench, it's about 19,528 versus 16,987. And for single core, 3,200 versus 2,876. Yes, the 9950X is going to feel a little faster, but it's a full-fledged desktop CPU. For Puget Bench, having a dedicated GPU pretty much always wins, even if you've got a 5060 Ti, at sort of the bottom of the stack. It doesn't matter. There's still some serious GPU horsepower there. But on the other hand, for an APU, this is an impressive result. That APU's got some horsepower. Gaming performance. Gaming performance on Strix Halo is surprisingly good, but keep in mind that it is an APU, and a DGPU is always going to be better, and a 5060 Ti, it's honestly not bad. But I want to show you Clair Obscur, because if we start with the graph, and we start with the 1440p graph, it's 46 FPS versus 23. It's like, oh, this isn't playable. What are you talking about? It's the preset, the Epic preset. It's an APU, it's using system memory, and so really high resolution textures, things like that, it struggles a bit. But look, the 5060 Ti also struggles with 1% lows. Check out this OBS capture that I captured directly from CachyOS though, playing with like the medium preset. This is a much, much better situation in terms of frame rate and 1% lows. Some of this is the engine. I mean, Clair Obscur is really not super well optimized, and the Epic preset is very, very demanding, and that's why the 1% lows, even with the DGPU, is 14 FPS. So if you just are snowblind by graphs, it really doesn't tell the appropriate APU story. The 1080p performance is a little better, 30 FPS with the Epic preset, but if you just turn the textures down, you will have a much, much better gameplay experience. North of 60, 70 FPS is easily attainable. Cyberpunk fares a bit better. About 60 FPS on the Ultra preset, and yeah, if you turn that down, it will do even better. Of course, the 5060 Ti is also killing it here. 1440p, no, look, there's not really a lot of difference between 1080p and 1440p. The bottleneck is not the number of pixels. It is a very playable experience with 1440p, and generally across a whole, wide library of games, the performance here is pretty good at 1440p. This APU is shockingly good. And that's true with Deus Ex Mankind Divided, and it's true with Final Fantasy Dawn Trail. Even Monster Hunter World runs pretty well at 1080p and 1440p. Older titles like Shadow of the Tomb Raider, they run great. And they also run great under Linux. The point of this, though, is that for this system and the cost, yes, this is a system that can game. You can do gaming on this system. But I think it's overshadowed a little bit because the people that are interested in using this platform for AI are probably going to be ahead of the people that are interested in using this for gaming. This is a portent, a herald of things to come for APU gaming. I can see a light at the end of the tunnel. Was not expecting APU gaming to be this good this quickly, and yet here we are. Now, let's talk about the AI experience on Windows. AMD is doing a lot of work here, and they realize the optics of some of the past transgressions, let's say, are not really helping with their reputation. One of those, the big one that especially a lot of users tripped over in our forum, is the 64 gig limitation. Even if you could manage to reserve more than 64 gigs of VRAM, a lot of the system memory beyond 64 gigs was inaddressable in any context to the GPU. Well, this platform and the update and the software and the new Adrenaline and blah, blah, blah has been updated to support up to 72 gigabytes shared. Now remember, the BIOS options are very limited. And right now in Windows, you can see in Task Manager that it is set for 512 megabytes of reserved memory. So you wouldn't think that I would be able to run LM Studio at all. And in fact, a lot of people on the forum have reported, I can't run LM Studio because my reserved VRAM is 8 gigs or 16 gigs or whatever. If all of your platform stuff is fully up to date and your software is up to date, LM Studio has to have a relatively recent set of patches. That is no longer the case. Now here in LM Studio, we're just going to download these models. And if you're into the Linux thing, the Linux performance is going to be a little bit better because there's more CPU optimization. LM Studio is picking up our GPU configuration here. Again, I've only reserved 512 megabytes. But it's still picking up, oh, we can use 48 gigabytes because that's a sensible default in terms of what the system is able to reserve. But with the most up-to-date Adrenaline drivers, we can actually have 72 gigabytes. But again, depending on your software and whatever situation you find yourself in, it may make sense for you to reserve 32 gigabytes of VRAM for the GPU. Or I think 8 gigabytes is a sensible default. I wish that was an option in the BIOS. Probably in a framework BIOS update, they'll add that because that is sensible for legacy software. But then you can also just use more system memory if your software understands that this is a unified platform, which is not hard to do at this point in 2025. So I've asked the Google Gemma 3 12 billion parameter model to write an efficient Python program to search for perfect numbers. It did okay-ish. I mean, the more advanced models start talking about Mercenine Prime and the great internet Mercenine Prime search and algorithms that do a better job with this particular math problem. But this isn't a terrible result for a 12 billion parameter model, and also it's quite fast. All right, now let's try the same thing with the 27 billion parameter model. And the 27 billion parameter model is moving quite fast as well. The model's twice as big and half as fast, but still 10.3 tokens per second in LM Studio. And if you're looking for comparatives from Windows to Linux, that's comparing apples to oranges or penguins to something much less ornery than a penguin. It doesn't really compare. We can do 10 tokens per second on a model twice this size in Linux with optimizations. And this is also running all 62 layers on the GPU, which is a different experience on Linux as well. And while I was working on this video, OpenAI dropped their open weight models, the 120 billion parameter GPT. You can just download it and run it. You can download it and run it on this platform, even in Windows, at over 30 tokens per second. A little bit faster on Linux. This is an FP4 model, so 120 billion parameters is going to use about 63-ish gigabytes of system memory, but there's no arguing with it in LM Studio. It runs quite fast, 33.81 tokens per second. You know, this doesn't have the external GPU, this doesn't have the Linux hybrid thing, it's just that. On the Windows side, there is also ROCm and the stuff that AMD has been doing for ROCm on the Windows platform. They aim for it to be a first-class experience, but let's hear from Andre.
The way I look at it, the ROC is the bleeding edge. We put there everything, we run the CI, it's available for any developer out there to very, very quickly go contribute. We are pulling things, contributing it ourselves. And our Strix Halo Ryzen box, right? Okay, it's competing with that right now. So we have a horse in that race as well. But the reality is that I mean, they don't really need with this kind of AI type framework to really support Windows because their devices are not there. I'm really very much excited about this, and we spoke about that, about moving the work that is traditional Linux, moving it to Windows. I think we are the first one to do it right. We are first ones to do it with an interface that, so we talked about Onyx, we talked about VLLM, but even as the subsystem, as ROCm, is something that is easily transportable from the competition. So that's a huge benefit.
My takeaway from the interview with Andre was that one of the things that AMD is looking to do is take care of developers that are in the Windows ecosystem with Python and machine learning. They want the Windows developers to have a first-class experience with ROCm and, by extension, to an extent, RDNA. There's some rough edges with the whole RDNA, CDNA thing. Really, it's a first-class experience with CDNA, but RDNA is going to be a part of that. But if you're a Python developer and you want to run ROCm and have experience to the ROCm libraries, this is a great solution. And as I showed in the Linux section, you can use USB 4 and connect an eGPU, including CUDA GPUs, and have the best of both worlds. You can have CUDA and RDNA, or CUDA and CPU, because the monstrous CPU horsepower here, and memory bandwidth in a platform like this, whatever you want to do. But if you're a Windows user, primarily, and you want to run the Windows subsystem for Linux and have access to PyTorch and all of that, then yes, you can do all of that natively on Windows, and AMD has done a Herculean amount of engineering in order to enable that workflow. So if you're interested in that and maybe doing some separate videos on that or some other platforms, or you want me to test drive something because of something that you need for work or whatever, that's why the Level 1 forums exist. Hit me up there. Let's chat. Let's chat about your workflow. Let's chat about the work that you're doing. You can also get a preview of work that other people are doing on this platform on Windows and Linux. Literally the framework desktop, more generically Strix Halo, and see what the performance is and see how it shakes out. It's a very, very strong AI platform in terms of cost per dollar and the performance that you get. Even with 70 billion parameter, it's a Q4 model, so it requires about 48 gigs of memory, but still, it's pretty awesome. So what are the downsides with this platform? Well, you can look at the cost one of two ways. One, if you look at the 128 gigabyte, like small platforms from competitors like NVIDIA, they're like $3,000. I'm certain that when NVIDIA was putting those products together, they never expected AMD to have a product. And I'm certain that AMD never expected to have a product because this was designed for mobile. But they're able to kind of sort of pull out a win here. The software is very weird though. I've been really excited by the software because it's very promising for the future. And I, as a developer, don't necessarily see some of the shortcomings and missing pieces in the stack as all that much of an impediment. But there are certainly a lot of people out there that just want to do their work and they want to get it done. And that can be a little problematic because when we're talking about ROCm, the first class citizen for ROCm is CDNA. It is enterprise class GPUs. This is not enterprise class. AMD's software stack doesn't have the same level of maturity that NVIDIA's does. I don't think anyone would say that. At the same time, ROCm and what AMD is doing with their software stack is coming faster, farther than anything that anybody would have ever expected. And I want to explicitly not lump in Vulkan with that. Vulkan as an AI backend, just like the games, yeah, that's the same Vulkan, more or less, can work really well. And so there are projects like Lemonade where you can leverage the NPU and you can leverage a Vulkan backend and you can get all of the performance of this platform coming at it maybe from more on the GPU side and less from the RDNA. We sort of expect things that are in CDNA to be here and they're not, functionality to get at the amount of performance that's here. This platform, if the software were 100% polished and ready to go, would be a serious threat to what NVIDIA is trying to do with their 128 gig platform. They're small, like the codename Spark platform. I think, don't have hands-on that, gonna review it, gonna see. That platform is gonna have a serious competitive advantage with CUDA and the NVIDIA inferencing microservices, and that thing as an appliance to plug into the cloud for AI workloads, I don't think that AMD really has an answer to that. AMD does have their developer cloud, where theoretically, if you're working on small jobs on this, you could get some time with CDNA directly in the cloud and set up your tooling so that a job that you put together here, you can push to CDNA in the cloud, deploy that with Docker or whatever, and have that be up and running. But right now, for my experience, even though I put together guides on getting the Rock up and running on this, and you can do that with Docker, and it's a lot of fun to play troubleshooting simulators sometimes, I have a better experience using the CPU side of this, and I have a better experience with the Vulkan backend. And Vulkan doesn't really technically have anything to do with ROCm or the Rock or anything like that. And Vulkan is actually, as I said, better on CUDA hardware than CUDA for very long context window models, which is pretty amazing. So it's a lot of words to say. Sometimes you don't want to play troubleshooting simulator. You just want to touch grass. So I get it. It's not all roses, but it is really exciting that this is as powerful as it is. If I were building the AI hotel from Altered Carbon, this plus an eGPU or two is probably where I'd start. It's the beginnings of something that's going to take shape and be in a 250 watt power envelope and have some serious AI computational horsepower for multimodal models. But again, the software's not there. You're going to have to DIY the software. I'm Wendell, this is level 1. This is definitely not the last video that you're going to see on Strix Halo, but I would love to know from you what you're going to do with this and how it looks and how it shapes up and the sort of workloads that you might be interested in running on it. Hit me up in the forum. Let's chat. Let's run some workloads. See what happens. I'm Wendell, this is level 1. I'm signing out. You can find me in the level 1 forums.